What are the key differences between Kotlin and Java? Theory. This question explores your understanding of Kotlin's design philosophy and its relationship to Java. It tests your knowledge of language features and how they compare. Explanation. Key differences often include null safety. Kotlin has built-in null safety through nullable and non-null types, reducing null pointer exceptions. Java requires explicit null checks. Conciseness. Kotlin generally requires less code for the same functionality due to features like data classes, extension functions, and lambda expressions. Interoperability. Kotlin is designed to be fully interoperable with Java, allowing you to use existing Java libraries and frameworks in your Kotlin projects and vice versa. Coroutines. Kotlin provides built-in support for coroutines, a lightweight way to handle asynchronous operations, improving performance and readability compared to Java's threads. Smart casts. Kotlin's smart casts allow the compiler to automatically infer the type of a variable after type check, eliminating the need for explicit casting in many cases. Data classes. Kotlin's data classes automatically generate equals, hash code, and toString methods, simplifying the creation of classes that primarily hold data. Though explain Kotlin's null safety system. Theory. This is crucial as null safety is a major selling point of Kotlin. It tests your understanding of how Kotlin prevents null pointer exceptions. Explanation. Kotlin distinguishes between nullable types, declared with a, and non-null types. By default, types are non-null. If you want a variable to be able to hold null, you must explicitly declare it as nullable. The compiler enforces these rules, preventing you from accidentally assigning null to a non-null variable. The safe call operator, dot, and the lvs operator provide concise ways to handle nullable values. What are data classes in Kotlin, and why are they useful? Theory. Data classes are a powerful feature for simplifying the creation of classes that hold data. This question tests your understanding of this feature and its benefits. Explanation. Data classes are classes automatically generated by the compiler. When you declare a class as a data class, Kotlin automatically generates equals, hash code, and toString methods, as well as a copy method. This is very useful for creating classes that primarily hold data, as it reduces boilerplate code. What are extension functions in Kotlin, and how do you use them? Theory. Extension functions allow you to add new functionality to existing classes without modifying their source code. This tests your knowledge of this useful feature. Explanation. Extension functions are declared outside of the class they are extending. You define them using the class name as a receiver type. They can be called as if they were member functions of the class. This is useful for adding functionality to classes you don't own, e.g., classes from a library. Explain the difference between val and var in Kotlin. Theory. This tests your understanding of Kotlin's variable declaration keywords and mutability. Explanation. Val declares an immutable variable, read-only. Once assigned a value, it cannot be changed. Var declares a mutable variable. Its value can be changed after it is assigned. What are lambda expressions in Kotlin? Theory. Lambda expressions are a core feature of functional programming in Kotlin. This question tests your familiarity with them. Explanation. Lambda expressions are anonymous functions that can be passed as arguments to other functions or stored in variables. They are defined using curly braces and can take parameters and return values. They are concise and useful for implementing functional programming patterns. What are coroutines in Kotlin, and how do they work? Theory. Coroutines are Kotlin's lightweight concurrency mechanism. This question tests your understanding of asynchronous programming in Kotlin. Explanation: Coroutines are a way to perform asynchronous operations without the overhead of threads. They are lightweight and efficient. Kotlin provides built-in support for creating and managing coroutines. They work by suspending and resuming execution, allowing multiple coroutines to run concurrently on a smaller number of threads. Art explain the concept of smart casts in Kotlin. Theory: Smart casts are a helpful feature that reduces the need for explicit type casting. This question checks your understanding of how they work. Explanation: Kotlin's compiler can automatically infer the type of a variable after type check. If you check if a variable is of a certain type, the compiler will smart cast it to that type within the scope of the check, eliminating the need for you to explicitly cast it. Now, what are the different ways to declare an array in Kotlin? Theory: This tests your basic knowledge of data structures in Kotlin. Explanation: Kotlin provides several ways to declare arrays. Array of Uda smiley creates an array of the specified elements. Array of nulls Uda smiley creates an array of the specified size, initialized with null values. Int array, double array, etc. Specialized arrays for primitive types, which are more efficient than generic arrays. Array Uda smiley creates an array using a lambda expression to initialize the elements. Thus explain the difference between and in Kotlin. Theory: This question tests your understanding of equality in Kotlin. Explanation: Checks for structural equality, whether the two objects are equal in terms of their content. In most cases, this uses the equals method. Checks for referential equality, whether the two references point to the same object in memory. This is equivalent to Java's